We will try to solve some problems. We have an optical fiber of length L is equal to 8 km, and there are no splices and connectors in between the 8 km. The mean optical power launched into the fiber, that is the input power, is PS is equal to 120 microwatt, and the power output P0 is equal to 5 microwatt. You are asked to find the overall signal attenuation in dB. So direct application of formula alpha dB into L is equal to 10 log the whole of the PS by P0 is equal to 10 log of 120 microwatt by 5 microwatt is equal to 13.802 dB. You have another question. You are asked to determine the overall signal attenuation for the optical fiber of length L is equal to 20 km, which is spliced 2 kilometers apart. That is the interval between the splices is 2 km, and each splice gives an attenuation of 1.5 dB. So you are given the mean optical power launched into the fiber, that is the power input is 200 microwatt, and the power output of the fiber is 15 microwatt. You are asked to find the overall signal attenuation in dB. So we have the formula alpha dB into L. Well, L is the length of the fiber is equal to 10 log PS by P0. Directly apply the formula. So alpha dB into L is equal to 10 log PS by P0 is equal to 10 log 200 microwatt divided by actually 15 microwatt. So the answer is overall attenuation due to the fiber is 11.249 dB. But now there are 9 splices 2 km apart. The total length is 20 km. So there will be 9 splices in between at several points along the fiber 2 km apart. So the total attenuation due to the splice will be 9 into 1.5 dB will be equal to 13.5 dB. So the overall signal attenuation is the sum of the attenuation due to the fiber and attenuation due to splices. It's 11.249 plus 13.5 is equal to 24.749 dB. So another problem, an optical power of 10 microwatt is fed into fiber of length 10 km, and the output power is found to be 5 microwatt, and there are no splices or connectors to the fiber, so they do not contribute to the overall attenuation. You are asked to find the overall loss in dB per kilometer. Alpha dB is equal to 10 by L into log PS by P0. Direct application of formula is equal to 10 by 10 to log 10 microwatt by 5 microwatt. The answer is 0.301 dB per kilometer. So another problem, the input optical power to a fiber of 20 km length is 10 microwatt. The output power is only 5 microwatt, and the fiber is spliced 2 km apart, and each splice introduces a 1 dB attenuation. You are asked to find the numerical input output power ratio. So direct application of formula alpha dB into L is 10 log PS by P0. It is 10 log 10 by 5, that is a 3.01 dB, and loss to splices, there are 9 splices, each spaced 2 km apart, and each splice contributes to 1 dB of loss. So total loss is 9 dB. So the due to splices, the overall loss will be 9 dB plus 3.01 dB is approximately 12 dB. So again you are asked to find the ratio PS by P0, that is the numerical input output power ratio. So PS by P0 will be given by the expression 10 raised to 12 by 10, that is 12 dB is equal to 10 log PS by P0, and PS by P0 is actually equal to 10 raised to the total loss by divided by 10, that is 10 raised to 12 by 10, 10 raised to 1.2 is 15.85. It is a ratio, and there is no dimension. Thank you for listening.